This is an example that you're going to be incorporating. Each person is going to incorporate into in their groups. So I'll be writing up all these steps in an additional document so you can have it for quick reference, but right now we're just writing it out. So in step one, I'm going to give you your function that you're going to use, you know, the negative t squared over 2 plus 15t or some other function. I'm going to give you your function, the times that you're going to use for that function to generate the positions, and the graphs associated with that function. So you know exactly when you're starting to plot the points, the shape of the graph that you should be drawing. Otherwise, it can be a little arbitrary. So let's say that I'm going to use this function from last time, negative t squared over 2 plus 15t. That's my function, and a particular time interval that I'm going to use is t equals 1, 3, 5, 7, and 9. It's very similar to what we did last time, 0, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. I'm just giving you a different time set right now. Okay, so step one, function. We have the function here. It's a deceleration function. This is my time gap. And the graph, the shape of the graph that you're going to draw, and what you have to do is you have to plot your points. So I want to see the points on the graph. So the shape of this particular function is going to look something like this. But what you're going to do once you generate your positions, you're going to just plot those points on this graph. I want to see the actual plotted points, you know, the X, the graphs labeled, the axes labeled. So this will be position in meters, this will be time in seconds, and so on. So you have that, you have your function, you have your times, and you know what kind of graph is associated with this function. The graph is going to look like this for this function. So now step two, we want to generate our XT data table. All right. And on the final, that'll be worth 20 points. And I'll show you why in a second. And so the first one here, well, this is just a given, so no points there. So we have the function up there. X is a function of time. So when t is equal to 1, we just replace t with the number 1. Okay, that's going to be 14.5. And then when t is equal to 3, it's going to be equal to 40.5. You can do that yourself just to confirm. And then when t is equal to 5, x will be equal to 62.5. T is equal to 7. X will be equal to 80.5. And then when t is equal to 9, position will be 94.5. And it doesn't matter the units, we can say meters, kilometers, but in our case, we're going to say megameters, and I'll explain that as we get there, because what I want you to do is I want you to take the megameter and convert that to miles. Okay, so basically, I'll show you what I mean visually in a second. So, because we know that the basic unit of distance is the meter. So if we convert to different types of meters, we can, especially with megameters, we can have a more realistic distance that we're traveling from LA to some other place. So one of the good units that we can use is the megameter. We can go up to terameter or petameter, but that would be even more descriptive of an actual distance that you're going to be traveling when you're doing a road trip. So those are our values. You can already see that the gaps, you may or may not be able to see that the gaps are actually getting smaller as we go up in time. So now that we've calculated all that, step 3 would be to, again, I'm gonna have all these steps in a document. Evaluate if the nonlinear data table has decreasing or increasing gaps. All of this data will be nonlinear. We just have to evaluate if the gaps are decreasing or increasing. No problem. All right, so, yep. So if there are decreasing gaps, as we see here, the first velocity that you calculate, and this goes back to last time when we were calculating those velocities based on if the gaps were increasing or decreasing. If the gaps are decreasing, the first velocity is going to be at t is equal to 0. Well, in this case, we don't have 0. And since the gaps are decreasing, that first velocity that you're going to calculate is at t is equal to 1. Okay. You always start off with the first time in the interval in the set. So if there are decreasing gaps, the first velocity you calculate will be at your first time. And I'm just going to denote that by t is equal to t1. Your first time could be 0. In this case, the first time is 1. Your other first time could be 0.36. Whatever that first time is, the first velocity you calculate will be that velocity at that time. In this case, the first velocity that I'm going to get is going to be at t is equal to 1 second, because that's my first time, or my t1. If the gaps are increasing, my first velocity will be it'll be 0 at t equals t1. So that's for increasing gaps. Let's put this to use from what we just calculated. Right now we have decreasing. We'll see an increasing case based on the function that you're going to be given in your final exam for your project. So we're just going to do this as an example because this is going to be long enough. We're not going to do an increasing example, but based on the function that you're going to get, you can determine yourself if the gaps are getting larger or if they're getting smaller. That should be easy for you to do. If not, let me know. So let's put all this data into an XT data table first. Okay, so we calculated the positions. Now we're just going to generate the table. So X will not just be in meters, but it'll be in megameters. That's going to go back to our conversions. And I'll be talking about that down the line. Time is in seconds. So our first position was 14.5 at 1 second. My second position at 3 seconds, 40.5 megameters. 62.5 at 5 seconds. 80.5 at 7. 94.5 at 9. So that's my data table. That's my position time data table, which we've seen many times before. The gaps are decreasing. We can see it's going from 26, 22, 18, 14, getting smaller. So what you can do as a reminder to yourself, you can say something like this on the side. Decreasing gaps, that tells you right away that whatever my first velocity is, that value would be the velocity at 1 second. That's my first time in this case. Other cases would be 0, that we've seen before. So this is just a new set of times, interval of time, set of times. So let me get my first velocity. Well, it's going to be delta x over delta t. That's my equation for velocity. And that is going to be between 1 to 3 seconds. That's my first pairing of points. My velocity will always be the difference between a pair of positions over time. We go the first 2 positions over time, and then the second 2 positions over time, and so on until we get to the end. So x final minus x initial, t final minus t initial, and that becomes 40.5 minus 14.5. 3 minus 1, final time minus initial time. It's my first instantaneous velocity. My first slope on this curve. That comes out to be 26 over 2. which is 13. Well, I'll put the units for right now. Megameters per second, but successfully I won't put the units, but we know what they are, but just based on the data table here, megameters in seconds. My second velocity, which exists at time 3, will be 62.5 minus 40.5, the next 2 points, over 5 minus 3. This is always going to be 2, just 2-second gaps. That's going to be 22 divided by 2, which is equal to 11. Be 5 delta x over delta t. 80.5 minus 62.5, 7 minus 5. 18 divided by 2, which is 9. You can see the pattern. The gaps in velocity are in increments of 2. 13, 11, 9. You probably predict the next one to be 7, 5. Be 7 delta x over delta t. 94.5 minus 80.5 divided by 9 minus 7. That gives me 14 divided by 2, which is 7. And if we want to go to 9, which we should probably do, just to account for that V9, the next velocity, or you can stop here, whatever floats your boat, it doesn't matter. You get the idea that the gaps are going to be 2. But again, just for good measure, delta x over delta t. Then the gaps would go from 22 to 14. I have to recalculate to see what the next gap is going to be, so I won't do that one because I don't want to make anything up. And it's not that important anyway. We have all that we need. Okay, 13, 11, 9, 7. Are there any questions so far on any of the parts before we go forward? Because this is an example that you're going to be using for your actual project.
I have a quick question. Before you calculated the velocities, you said it was decreasing. How'd you, but before calculating the velocities, it looks, okay, after calculating the velocities, you can see that it's decreasing because the numbers of the velocities are getting smaller. How did you get that it was decreasing before calculating the velocities?
I'm looking at the gaps. So the gaps between here, 14.5 to 40.5 is 26. And then 40.5 to 62.5 is 22. They're getting smaller. The gaps are starting to shrink.
The gaps. Okay, thank you.
Yes, decreasing gaps. Yep. They're both, Arthur. They're both, the graphs in the beginning are exact graphs. Nothing arbitrary about it. Yep. So that's why I'm going to give you that graph, or the graphs for your functions that you can use. Now, all you have to do is just, when you plot your points, you know what kind of graph that you're going to draw. But that's all real. It's not made up. Okay. So I'm going to erase that. And of course, the accelerations, it's going to be a constant value. So we calculated our velocities. So step 4. is to generate your VT data table from your XT data table points. So you get your VT data table. We already calculated the velocities. Now let's just place all those velocities in a VT table. It's going to be in terms of mega meters per second. And all the way down. Of course, megameters per second, or any distance per second is going to be megameters per second squared for our acceleration. But anyway, my first velocity that I calculated was 13 megameters per second at 1 second. Then I have 11 at 3. I have 9 at 5, 7 at 9, and of course, you can see the pattern, 5 at 11, going down by 2 for every 2 seconds. So we can see that's going to be -1, right? So as long the gaps are proportional, so we're going to get the same value that we got in the other previous example, but it's not meant to be that way. It just happens to be that way. So let's see, that's our data table for the velocity. Let's insert this. 7 steps. Step 5. Generate your AT data table from your VT data table points. In order to do that, we got to calculate the accelerations for each pair of points for all the times. All right, just like we did for positions, we're going to take these 2 points, 11 minus 13 divided by 2, 9 minus 11 divided by 2, 7 minus 9 divided by 2, negative 2 over 2, negative 2 over 2. Yes.
Wait, like, why did you put a 9? Isn't it supposed to be a 7?
Oh, yeah, right. Sorry about that. Yeah, my 7s and 9s mixed up, yeah. Very good. Yeah, that's why. Okay. So generate your AT data table from your VT data table points. My first acceleration will be delta V over delta T. And that's from 3 to 1 or 1 to 3, you know, same. So 11 minus 13 over 2. And you see where this is going. Negative 2 over 2. Megameters per second squared. And since everything is built off of constant acceleration, you don't even have to calculate anything else. You know it's going to be -1, -1, -1. Because by the time we get to this point, we go from an x squared function to a line to a constant, which is the acceleration. We really don't need to do the rest because we know intuitively, physically, that's going to be a constant value for acceleration, constant acceleration for all time. But just to do it for the moment. 8-3. And then I'll just go 9 minus 11. Five minus 3, -2 over 2, -1. Squeeze that in here. Base of 5, delta V over delta T. What we got? Yeah. 7 minus 9 over 7 minus 5. And then so on. So the pattern is established. We got that all. It's the same acceleration for all time. It's constant. And that's what you're going to get, whatever you may or may not get -1 for your accelerations, but whatever the acceleration is going to be a constant. That's what it should be. So the AT data table will look like this. One. So it's constant throughout all of time. We have our AT data table. We've calculated all the acceleration. So now, step 6, we're going to draw the motion map. This should just be something real quick. So something like this. We know that the gaps are going to get, the motion map is going to be reflecting the gaps that are decreasing or increasing for all time. So we know that we're going to have a large gap in the beginning and then successively smaller gaps. And just do your best to reflect that for all the times in the problem. So you don't have to track down here the different points, but you don't have to track those points. You've already depicted that the gaps are getting smaller by the motion map here. So here would be 1 second, 3 seconds, 5, 7, and 9. So that's all you have to do for the motion map part. Go back up here and just a portion of points. So this is going to be 20 points. Step 5. 20 points. Step 3 will be 2 points. Yeah, I think 2. I have also 20 points. Okay, so you can get an idea of what of the points for each part. The reason why step 2 is going to be 20 points because 10 points for the calculations, 10 points for the table. Because I'm going to have 5 times for 5 different positions in the calculations and 5 positions for 5 times in the data table. So 20 points, 2 points there, decreasing gaps, velocity, okay, just 2 for itemizing that. So for 20 points, same way as the step 2 when I was generating the positions, the position time data table. Same logic there. Same thing goes for step 5. Step 6 is 2 points. And last step. Using a mass of 7 kilograms. And your AT data table value. You're to calculate the force. Calculate the force and I'm going to graph the force via an force time graph. So the acceleration was -1 megameters per second squared. Our mass is 7. And Newton's second law, F net is equal to mass times acceleration. 7 kilograms times -1 megameters per second squared. And since this is in terms of megameters and not meters, we're not going to say newtons, but we're going to say meganewtons because of the mega.
Mr. Kelly,
Yes,
is it alright if you scroll up just a little bit for a second?
I will. So -7 meganewtons because of the megameters. Okay, where do you need to go?
That's perfect. Thank you.
Yeah. So that's what we have, and now the next part. So make sure that I hope you've written all that other stuff down. Again, I'll put all the steps in a document so you can reference that. Okay, you got everything?
Yes, thank you.
All right. And so now let's go to the next. So have you guys seen permutations before? In your math classes?
Yes.
I'm sorry. Did you say
For
you
me,
have?
yeah.
Okay. Well, maybe the rest of you are gonna get it. You know, where whatever depends on what math you're in. You know, math 3 or something like that.
Yeah, pretty much.
Yeah. So just briefly, permutations. It's like, you know, it's basically taking a set of data and making different technically not combinations, but different arrangements of the data. Not unique arrangements, but different arrangements that do repeat, but then the combinations will be those arrangements that don't repeat. So permutations and combinations are sound like the same, but they're not. So anyway, see the basic function for permutations. So basically, I'm taking 9 pieces of data 2 at a time to generate a unique arrangement. And so that basic formula is going to be, you don't have to do this, but I'm just showing you what was behind the scenes. So we 9 factorial over 9 minus 2 factorial, blah, 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 blah. I do all my stuff and I get up to about 72 arrangements, which I got about like 28 to 30 unique combinations out of those arrangements, because not all of those arrangements are unique. Some of those arrangements repeat, but never mind that. So that being said, let me write out all of the functions that you're going to be using for each group and the different time intervals that you're going to be using. So here, so the first function that we're going to be choosing from is one we just used. And then C will be so these are the different functions that every group is going to be choosing from. So based on the assignment of the arrangements there. So we have x of t so now I have 6 time intervals. Okay, so I have a time interval, it's like very similar to the 1, 3, 5, 7, 9. So I have a 1.2, 1.4, 1.6. So everybody needs to write this down. So when I address your group, like group number 1, you're going to have these different combinations. Now you have this all written down, so you know which combinations to use. So like if you have a combination of A, B, you're going to use the A function with the B time gaps and generate everything in steps 1 through 7. So if group member 2 has like CF, you're going to take that function and that time gap, do steps 1 through 7. And the third member, say, has ED, okay, then he or she's gonna take that set of data. So that ensures that you have unique sets of data. You guys can work together, because for the process is going to be the same, but the data sets are going to be different, so that everybody can contribute to the whole project. All right, so that's why I did that. Okay, so then here's D, or the second time interval. This time interval is going to be 2.3, 2.6, 2.9, and then this reminds me of a particular block scheduling at school. The odd days, or Monday, Wednesday, Friday, is ACE, and the other days are BDF. So T is equal to, or F, 3.67, 4.34, 5.01, 5.68. So again, these over here are your position time functions, of which we use the first one as an example to generate all that data, so that you're going to be doing the same thing, but for your own unique set of data. And over here are the time, the time sets, time intervals here. So originally I had ACE BDF, but I didn't get enough unique combinations, so I had to kind of improvise and fill in some more. So I went to B1. And this will be sorry, keep it simple. 2, 9, 16, 23, 30, and 37. D1. .43. So now I'm going to increment these by 0.43. 3.86. 4.29. So make sure you're writing all this stuff down. Don't know which one you're going to get. They're all five. Each interval has 5 times in different increments. Then F1. .77. 5.54. 6.31. 7.85. Actually, I had to do a few more of these. Okay, so far we have 9 data points. And actually had to add 2 more. Actually 3 more. B2 is going to be equal to 3, 8, 13, 18, 23. Yeah. And then D2 is going to be the same as the F1 time gap. So you're looking at F1 here. That's the same thing as D2 and F1 are the same. So I'm just not going to repeat that. And then F2, last one. 5, 13, 21, 29, and 37. So it's actually 12 sets of data, so I can recombinate that, but anyway, it's quite important. So those are my 3 functions. Make sure you have all this written down. Does anybody need to see anything else? Let me scroll up.
To the bottom, please.
I'm sorry?
Can you scroll to the bottom, please?
Yeah. So we got that. So now for each group's combinations. So I want you to write this down first. So when I assign such and such A, B, you know which one you have to choose from. Crank all of your data from steps 1 through 7, report it onto the Google document. You'll be done for your final exam. All right, so let's get to this. You guys finish writing that up and come back in a moment. All right, now each group, let's pay attention to, each group pay attention to your combinations. So group 1, you can decide which combination that you want, but I'm going to give you 3 combinations for you to choose from. So group 1 has AB, AD, and AF. Okay. I should just put this on your Google Doc, but anyway. Group 2, you have AB1, AD1, AF1. So the permutations are combinations that's very good for random number generators, sequencing, it's, hashes that you use in programming. It's a very good baseline or starting point for computer programming. So understanding that and the logic behind it. So group 3, BC, BE, and B1C. Group 4, B1E, CD, and CF. Group 5, CD1, CF1, and DE. E1E, EF, EF1. Group 7. AB2, AD2, AF2. Group 8, B2C, B2E, CD2. Group 9, CF2, D2E, EF2. So I have 5 more, so I'll just lucking out, and I'll repeat those. So I should have added a few more points, but that's all right. Does everybody have that? All of your groups? Anybody need to see anything?
There's no group 10.
I'm continuing in a second, but I'm just stopping for the moment. Just pausing to make sure you guys have it. All right, so and there's actually group 11 is like 2 people, but I'm just going to make up some more time sets. Okay, so we'll do B3C, B3E. There's no B3, but I'm gonna give that to you. And CD3. In group 11, there's 2 people there. I think there's, yeah, 11. CF3, D3E, and that's it. All right, so let's get those B3, D3, F3 times for groups 10 and 11. So groups 1 through 9 can go to your, I mean, there's 15 minutes right now. You can get started on some part. At least there are calculations. You guys can help each other out, you know, how do I do this part? But of course, there's not going to be anybody just waiting for an answer because you're going to generate your own answers. I think it's going to take a lot of time just to break you out. So you can just sit tight. I'm going to give those B3, D3, D3, and F3 times. B2 was that. Keep life simple, I guess.
Mr. Kelly, could you scroll up a slight bit?
I will, after I finish this. 3.5. No problem. Okay, so you got your B3. So everything's in unique combinations. Scroll up to where?
Like right there.
All right. Questions? Our way. We have 12 minutes, so we can, no need to get started today because it won't. We don't have enough time to do anything. But obviously, you can work this on the weekend. I encourage you to do so, and then come back Tuesday and Wednesday, I think it is.
Wait, where do we turn it in?
You turn it in under your Group 1 project or your group project. So yeah, it'll be Tuesday and Thursday. Yes.
So for the different combinations you gave each group, everyone in the group do one of the combinations, or does everyone have to do a different combination?
Yeah, that's why I gave it to you. It's groups of 3. So you choose which one you want to do, and the other 2 people choose from the other 2. You could do this one. I mean, it's up to you guys. You know what I'm saying?
Yeah, thank
as
you.
an example, yeah, Miles, Caleb, and yeah, Edgar, I guess, or some other combination of the 3. So you have a choice.
Mr. Kelly,
Yes.
you said turn it in. There's 2 ones. There's the physics project with all the groups that we've been doing.
Yeah.
And then there's the physics exam. Which one do we make a doc for, and which one?
It'll be the physics project. So let me get rid of the exam one.
Oh, okay.
Yeah.
Wait, there's no group 11 on the physics project.
Yeah, right there.
No, on the groups project there are like.
I'll make another
groups.
document. I'll make one. Yeah. So that's not important right now, right? Because once you generate that, that's going to be the final step. That's nothing. But yeah, no, I'll have it up. Yeah, fire away. So we just 10 minutes on this. Any other parts that we need to have clarification on?